Okay, welcome back, guys. We have another question from the second chapter of the engineering mechanics by Meriam, statics, and in the equilibrium position shown, the resultant of the three forces acting on the bell crank passes through the bearing O. So basically, these three forces can be replaced with one force that the line of action is going to pass through this point O. And we need to determine the vertical force P first. And in the second part, the question is asking us, does the result depends on the angle theta, which is what we have in here. So when the line of action of these three forces passes through O, which means these three forces can be replaced by the resultant force. And if that resultant passes through O, it won't make any moment about point O. So basically, the sum of all moments about point O is going to be 0 because there is no result distance vector. So r cross f, where the r is 0, there won't be any moment. So this will be 0. And now let's find the moments of each of these forces. And these two, as we can see, they are perpendicular to this. So basically, the moment for each would be, we can see the moment is first of all counterclockwise, so it's positive. So for this one, the distance would be 4 plus 4. So we have 8 inches. And for the 60 pounds, again, same moment, same direction, counterclockwise, so plus 60. And the distance this time is 4 inches. So these two are out, and we are left off with the moment of P, which we need the vertical distance, so we can resolve the force into two components, one parallel to the crank and the other one perpendicular. So we can see the parallel one is going to pass through O, so no moment from that one. And the other one, since we know this angle is 20 degrees, this angle here is also 20 degrees, so this will be P cosine of 20 degrees. And we can see the moment about always clockwise, so negative moment 20, P cosine of 20, and the distance that we have is 5 inches. So, and this will be equal to 0, and we should be able to find P in here. So basically 40 times 8, 320 plus 60 times 4, 240 over 5 cosine of 20 degrees. Let's see what we get. So 320 plus 240 over 5 cosine of 20. So this is going to give us 119.2 pounds as for the force P. So we found the vertical force P, and the question is asking us to determine the resultant is dependent on the angle theta in here or no. Let's just clean up the figure. So looking at this, if the crank opens, obviously the angle between P and this vertical line, which was 20 degrees, doesn't change, which means this moment is not going to change. Same for the other one. If the crank changes the angle to this, again, we have same distance for these two forces. So the moment of these two are also the same. That means changing the angle theta won't change anything. And the result for P is not dependent on theta. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.